Hi everyone, this is our Big Data Analytics project. Our topic is about citing trading strategies in Chinese futures market. Our objective is to use machine learning classification algorithm to predict the price movement of futures assets based on the historical price data and decide whether to buy or sell given particular market signal. Compared to traditional finance models, which cares more about the mechanism behind that drive the price movement, machine learning models will focus more on data itself and try to extract features out of data that may not be totally considered by traditional finance models. And that's where we believe machine learning has a potential in trading analysis. By using tick-by-tick financial data downloaded from the Green Financial Terminal, which contains lots of Chinese financial markets data, there are four types of futures considered in our project. Their name and index are displayed on the PowerPoint. There are three types of training models we are using. The first is logistic regression, the second is decision tree, and the third is neural network. We use Spark and Python for logistic regression and decision tree, and we use the Keras package in Python for the neural network analysis. We use R to transform the original tick-by-tick data into minute-by-minute data. We generated open, close, low, high price in each minute and generate the return in 5 minutes with 1 minute time delay as well. And the open close price is the price at the very beginning and the very end of each minute. Low and high price is the lowest and the highest price in each minute. And we care about whether the return is positive or negative, and we do a primary summary on the ratio of positive return for each futures dataset. And it turns out to be around 45%. Therefore, if we can get a prediction accuracy above 60%, that would be desirable because 60% cannot be obtained by randomly guess.
I'm going to introduce how to use logistic regression model in our project in order to predict the future trading strategy. So our target value for the logistic regression is the selling strategy after 5 minutes given the current data. We use 0 to indicate if we want to use a sell strategy, and we use a 1 to indicate if we want to use a buy strategy. So for the first step, we will train the HC1 index data using 4 feature set, and we will determine which one is the best feature set to use for the logistic regression. For the first feature set, we use high, low, open, and close. For the second one, we added the previous minute high, the previous minute low, the previous minute open, the previous minute close, and the previous 5-minute return. And for feature set 3, we use high-low open close and the previous 5-minute return and the best sell pressure. And for the last feature set, we use high-low open close and the differences between the closing price between this minute's data and the last minute data. And also we use the differences in closing price between this minute's data and the previous 2 minutes data. The training result of the H1 index is the table here. So for feature set 1, we have a test accuracy of 62.96, and our predicting time is 0.168, and the rest is shown in the table. As we can see that the predicting time is roughly done within 1 minute, so the model basically performs well in terms of efficiency. However, when we see the test accuracy, the highest test accuracy occurs at feature set 1, which is high, low, open, close. In the next 3 feature set, even though we have added more features, it doesn't really add onto the test accuracy. So for logistic model, we can conclude that only using high open close open, high low open close is the best feature set to train this model. And the below picture is the output model from Spark. So basically from the terminal, we can see that the prediction is made in 0.168 seconds, and below we can see the actual model, which is the coefficient between each of the independent variable. And in the next step, we will use the feature set 1, which we decide is the best feature set to use in the previous step, on all of the 4 indices of futures data to compare which index should perform the best based on our predicting model. So we can see that by using the same feature set, the IFB1 index only has a test accuracy of 51.57, and XU1 has a test accuracy of 55.79%, which means that the best data to fit into the model is actually HC1. This in future index is the best to predict future strategy using our logistic regression model, and below is the output from the terminal, indicating how long we use to make the prediction, and also the actual model, which is the coefficient between each dependent variable, or which is the coefficient before each independent variable. So for the next, I will perform a demo to see how to train the logistic model in Spark. First, since our original our dataset is in the CSV format, however, Spark only takes in TXT format, so we need to do some data transformation to decide the strategy. Also add in the feature set. So for this one, we use the H1 data as an example, and we use the feature set 4 as an example, which is high, low, open, and close, plus the previous 1 closing price and the previous 2 closing price difference. So this is the code to transform the data. It's waiting for because the data size is kind of large, so it took some time for the code to run. Oh, here it is. So now see here we have the H1 training data, and we have the HI1 training data, and we have the HI1 testing data. Now we can use PySpark to train the model, and here is the code to use in PySpark. We import the PySpark machine learning library on logistic regression, and then we open the terminal. So this is basically the command we use to submit a job to Spark. The first parameter is our PySpark Python files. The second one is the training data file path, and the third one is the testing data file path. So we run this command in terminal. Spark is running to train our logistic model. So after Spark finishes job, we can go to see the model it produced. In our code, we actually let the terminal to print the prediction model, so it should be inside this output somewhere. Okay, here. So here we see the prediction is made in 0 to 83 seconds, and the test accuracy is 0.540, and then the actual model and the coefficient of the dependent variables, the coefficient of the independent variables are as below. And so in this case, the test accuracy isn't very good. It is even worse than what we just guessed. So this logistic regression model probably is not suitable for this data.
To test the relation between the price movement and the previous price momentum, which is represented by the increment in price from previous minute to the current minute, we create feature set 4 and 5. Similarly, as logistic regression part, we calculate the difference in price between time t and t minus 1, time t and t minus 2, time t and t minus 3. And the fourth feature set is in absolute level, and the fifth feature set is the relative value of the feature set 4. For feature set number 6, we test Bessel pressure indicator, which is a complex defined version of feature set 2 and 3. It weighs each minute's data using the transaction volume and considers relative value of Bessel pressure to the previous Bessel pressure average. This idea is given by Karthik Mara in his blog, and you can see the details on website. And the code of calculation is displayed here. Use HC1 data file to generate the decision tree models for different feature set. And here I'm going to demo use the feature set number 3, which is the relative ratio of high close and low prices within each minute. So here's the code. We transform the data of the one that we just obtained from R. Other than primary feature set, we need the new feature set that we want to test on, and also we need the strategy value, which denote whether the return is positive or negative, and that is the target of the decision tree model. And here we just generate feature set 2, 3, 4, 5. At the very end, we want to delete those rows with non-values on the feature set because decision tree cannot handle it. So we add this thing. And finally, we save them as file train data and test data. Decision tree model is like this, and so here we add features as the relative value of close, low, high within each minute, and we will we will generate the model based on these two features. And here we just parse the data file into RDD of label point. Here we added the target value, which is strategy, and here is the vector that contains the two features. And when we train the model here and try to get the accuracy and try to predict it using the test data and try to get accuracy here, we can get the result. So here you can see the test accuracy is around 0.579, and the time we use is around 0.5 seconds, which is relatively short. So similarly, we can get the test accuracy and prediction time for all the 6 feature sets for HC1 feature. The speed is fast, and as you can see, the time is short, and the test accuracy is around 50%. Feature set 1 is the primary set, which contains less valuable value and has relatively bad prediction accuracy. We will discard it for future use. And for feature number 6, it's a more complex defined version of feature set 2 and 3, which reflect the high-close, low-price relation. However, it didn't prove the accuracy of prediction, so we won't bother to use it as well for the future. And we only use the feature set number 2 to number 5 to focus on the effect of high close low price relation within each minute and price increment. And now you can see the result for other features data for future set number 2, 3, 4, 5. The accuracy didn't attain 60% above, which means the model given those feature sets are not suitable for price movement prediction. We can see that decision tree is fast and we need to have a better defined feature sets to get better prediction performance. A good feature set is important for both logistic regression and decision tree classification. And we also see the accuracy is different for each data, which means different types of features has different sensibility to the feature set given their different nature.
Now I'll introduce the neural network mode. Since the prediction is a classification task, and we can use the neural network to make decisions. The neural network is an algorithm that uses multiple layers of nonlinear transform to map the input and output. The advantage of that is we do not need the feature engineering. The network can automatically put attention to those important features and negate those unimportant ones. It's able to learn those high-level nonlinear functions, such as picture. In the first picture, it was hard to use a single straight line to split the red line and the blue line, but if we transfer them into a new space, they are easily to be split out. But the neural network is hard to adjust those parameters, and sometimes it needs more training time. To build our model, the Theano backend is required to enable GPU acceleration, and the Python Keras library provides an API of building network. Here we train individual mode for each dataset. The parameter we use is using 4 layers and using the dropout as the regularization. The result is shown in the table, and for each mode we can have a test accuracy more than 62%, and we can have a relatively high training accuracy. That means this mode still exists some kind of overfitting, but overall its performance can have a better prediction rate than previously mode like the linear regression and decision tree. That means this mode, the neural network can capture the high-level relationship between the input and output. Here I'll introduce the code of our neural network mode and how to use it. The program consists of 2 parts. First one is used to read the CSV file and transfer them into a NumPy data array. Another one records how to build the network and the parameter setting. It will first load the data and then normalize it. After that, we use the Keras library to build the network. Finally, the mode is being trained and evaluated. Since we train value mode for each dataset, we have 4 network scripts and 4 data loading scripts. To run this mode, simply run the Python code. Some output given like this. First, it will show the network information, and then the training process is given. After training, the test accuracy is given. For this mode, we have a test accuracy about 67%. For the training accuracy, we have 86%. And this is how the neural network model works. In conclusion, the best strategy is based on neural network, since it can obtain the prediction accuracy above 60%. Profitable trading strategy is possible. In the future, we want to increase the accuracy for logistical regression and decision tree classification. We will try to explore some financial research to find a good feature set, or try to include other data set like the market index and relevant set price, rather than just use the historical data to predict the data itself.